Hey class, this is a screencast explaining sheet number 5, the decomposition reactions. So I'm going to be flipping back through the notes. So I would probably keep those notes like available. If you split screen the iPad or something like that, you'd be able to do it pretty easily. So let's take a quick look at what we have here for sheet number 5 for 1A with NaNO3. This is a decomposition reaction. The most important part of this is figuring out what kind of decomposition reaction it is. We have 6 choices. Hydroxides, sulfates, carbonates, chlorates, nitrates, and oxides. And I can see here that my compound is ending with NO3, which means what I have then is a nitrate. Now, what's good to know is to know what kind of metal I have, because with some of the rules, it matters if it's an alkali or group 1 metal, which is what sodium is. Na is group 1. So let's check to see what a group 1 metal does for a nitrate. So I flip back here till I get the nitrates. Nitrates, the nitrate of an alkali metal, that's sodium, that applies to what we have, on heating to yield nitrite and oxygen. Nitrite and oxygen. So I'm going to see whatever I have with NO2 and then with O2. So that's what I'm going to do for my example. So flip forward to get to here. And so what I get is I get my metal nitrite plus oxygen. That's what it says for an alkali metal. So Na has a +1, nitrite is NO2 with a -1, so those cancel. I don't have to crisscross that. And then oxygen is what I get there, like that. So now all I have to do is balance the equation. Now unfortunately, because I have a 3 here and 2 and a 2, I'm going to have to double something. So I double the one that's odd. I always do that. I think it makes life a lot easier. 2 for the NAs, so I need 2 NAs, 2 Ns, and I have 2 now Ns, and then 2 times 3 is 6 oxygens. 2 times 2 is 4 oxygens, plus another 2 equals 6. So actually putting the 2 in front of the NaNO3 and a 2 in front of the NaNO2 is all you have to do to balance that equation. Let's get rid of that so we can move on to the next one. Let's do another one. Okay, let's take a look at, why don't we do, let's just do letter B and see how that works. So I have calcium here and carbonate. So what's the rule for carbonates? Okay, let's see if carbonates decompose and how they decompose. So carbonates, it says except for the alkali metals, which is group 1. Calcium is not a group 1 metal. Calcium is a group 2. So this one will decompose. And it decomposes to get carbon dioxide and the metal oxide. So let's flip back and see what we get for carbon dioxide and the metal oxide. So carbon dioxide is CO2 plus, and then the metal oxide. So the metal is the first element in the carbonate. So calcium has a +2, oxygen has a -2. And because they're +2 and -2, there is no crisscross with that. So that's it. That's all I have to do. I have 1 Ca, 1 Ca, 1 carbon, 3 oxygens. 2 plus 1 equals 3 oxygens. So this is already balanced. So I have everything's done with this now. There we go. Let's take a look at some examples of when you have the words. So the first thing I do for the words is I write down the symbols and charges to get a formula on the left-hand side. So I get aluminum and then hydroxide. So aluminum is Al with a +3, and hydroxide is OH with a -1. That means I need to crisscross to get Al parentheses OH and then 3 underneath. So that's it right there, like that. Now how do hydroxides work? Let's flip all the way back to the beginning because I think it's one of the first ones that we did. They're hydroxides, except those of alkali metals. So is aluminum an alkali metal? Nope, it's not, which means it's going to work, which means I'm giving off water, or my products are water and the metal oxide, which is pretty typical. The metal oxide shows up a lot. Let me get back to where we were before here. There it is. So what I get then is water, H2O, plus, and then the metal oxide. Metal is aluminum with a +3, and oxygen with a -2. So I crisscross to get an Al2O3 like that. Then I get rid of the charges like that, and now I have to balance the equation. So here I have 3 oxygens and 3 hydrogens. However, notice over here I have 2 aluminums, so I need 2 aluminums here. Now that means that I now need 2 times 3 is 6 oxygens and 6 hydrogens. So over here I don't have 6 hydrogens, I only have 2 hydrogens. So what times 2 equals 6? And the answer, of course, is a 3. So 3 times 2 gives us 6 hydrogens here. That also gives me 3 oxygens. How many do I have over here? I also have 3 oxygens. So that means that 3 plus 3 is 6. So now I have 6 oxygens on both sides, I have 6 hydrogens on both sides, and I have 2 aluminums on both sides. So 2, 3, and 1 is what I get for the answer for that. Let's do one more, make sure we understand. How about, here's one. Let's just take a quick look at D. D says sodium chloride. So do we have any that's a +1 and a -1? So I'm going to crisscross to get rid of that. NaCl yields. Now we don't have any chlorides on here. So that means that it doesn't decompose. So that would be an easy no reaction, because the chlorides do not decompose, because it's not listed as one of ours that we have notes on. Let me see if there's another one. Maybe we'll do another one. I'm going to let you try letter F. How about sodium chlorate? Okay, so I do my symbols and charges like that. +1, -1 means no crisscross. And then let's go back to chlorates. Chlorates, no matter what it is metal chloride and oxygen. Metal chloride and oxygen. So let's go back and do metal chloride, which means Na with +1, chloride -1, plus oxygen, like that. And then 3 and 2 means I put a 3 here and a 2 here to get 2 sodiums, 2 chlorines, and 6 oxygens. And 3 times 2 is 6 oxygens. So that's it right there. All right, I'm going to let you finish that up and submit that then. All right, guys, nice work.